laser pointer. What if every person on earth aimed a laser pointer at the moon at the same time, would it change color? Answer: not if we used regular laser pointer. The first thing to consider is that not everyone can see moon at once. We could gather everyone in one spot, but let's just pick a time when the moon is visible to many of people as possible. Since about 75% of the world's population lies between 0 degree equator and 120 degree equator, we should try this while the moon is somewhere over the Arabian Sea. We could try to illuminate either a new moon or a full moon. The new moon is darker, making it easier to see our lasers, but the new moon is a trickier target because it's mostly visible during the day, washing out the effects. Let's pick a quarter moon so we can compare the effects of laser on dark and light sides. The typical LED laser pointer is about 5 milliwatt, and a good one would have tight enough beam to hit the moon, though it has spread over a larger fraction of the surface when it got there. The atmosphere would distort the beam a bit and absorb some of it, but most of the light would make it. Let's assume everyone has steady enough aim to hit the moon, but no more than that, and light spreads evenly after the surface. Half an hour after midnight, everyone aims and press the button. This is what happened. Well, that's disappointing. It makes sense, though sunlight baths the moon in a bit over a kilowatt of energy per square meter. Since moon's cross-sectional area is around 10 to the power of 13 square meters, it's bathed in about 10 power 16 watts of sunlight. 10 petawatts or 2 megawatts per person. For outshining our 5 milliwatt laser pointers, there was varying efficiency in each part of this system, but none of it changes that basic equation. A 1 watt laser is an extremely dangerous thing. It's not just powerful enough to blind you, it's capable of burning skin and setting things on fire. Obviously, they are not legal for consumer purchase in the US. Just kidding. You can pick one for $300. Just do search for 1 watt handheld laser. So suppose we spend the $2 trillion to buy 1 watt green laser for everyone. In addition to being more powerful, green laser light is near to the middle of the visible spectrum, so the eye is more sensitive to it and it seems brighter. The laser pointers we are using put out about 150 lumens of light in a beam of 5 minutes wide. This lights up the surface of the moon with about half a lux of illumination compared to about 130,000 lux from the sun. By comparison, the full moon lights up the Earth's surface with about 1 lux of illumination, which means that not only would our laser is too weak to see from Earth, but if you were standing on moon, the laser light on the landscape would be fainter than moon's light is to us on the Earth. With advance in lithium batteries and LED technologies, over the last 10 years, the high performance flashlight market has exploded. But it's clear that flashlights aren't gonna cut it. So let's skip past all of that and give everyone a night moon. You are not recognize the name, but changes you have seen on operation. It's searchlight mounted on police and coast guard helicopters with an output on the order of 50,000 lumens. It's capable of turning a patch of ground from night to day. The beam is several degrees wide, so we would want some focusing lenses to get it down. to the half degree needed to hit the moon. It's harder to see, but we are making progress. The beam is providing 20 lux of illumination, outshining the ambient light on the night half by a factor of 2. However, it's quite harder to see, and it certainly hasn't affected the light half.